This is for Year 12 methods, and it's how to find the range using the class pattern. I've got three different functions here. One of them has a restricted domain, the other two implied domains. The first one, G, is a quartic and has a restricted domain of negative 1 through to 4, so that obviously is the domain. To find out the range, I've already entered into the calculator, so I take what I've entered and I open up a graphing window and I drag it into the graphing window and I drop it, and there it is, but I can't see it. So I'm going to change the window to match my domain, so negative 1 through to 4, and OK. And then I'm going to go zoom auto and will automatically change the Y values to match that domain. So there's my graph that's drawn. I know that it is a quartic, so I might but it's only between negative 1 and 4. So analysis, gsolve fmin will give me my minimum Y value, and my minimum Y value is minus 43.53 to 2 decimal places. And analysis, gsolve fmax gives me my maximum value, which is 73 when x equals to 4. So 73, but it's not inclusive of 73, so a curved bracket, because x doesn't equal 4. So that's the first example. The second example is a quadratic that has a y-intercept of minus 16, and it's a negative quadratic. There's no restrictions on any value of x that can fit into a quadratic, and my domain then is R. Okay. So go back over and I have a look at this quadratic, edit, clear all, so that will clear any graphs that have been drawn. I've already pre-entered my graph, so there it is. I drag it into the window, zoom auto finds it right down the bottom. I know that my minimum value will be negative infinity, and my maximum value, analysis, gsolve fmax, gives me minus 14 and 2/3, which is where my minus 14 and 2/3 is. I have a square bracket because it's a turning point and the value of y does exist at that point. My third example is the square root of x squared minus 2x. Again, I'll come back over, edit, clear all, OK, and I've got the square root of x squared minus 2x. There are no negative y values, so the y values seem to go from 0 up to infinity. I get a 0 when I take the square root of 0, and I can take the square root of 0, so I'm going to have my range, which is going to go from 0 inclusive up to infinity not inclusive. Now the domain values, it looks as if we go from 2 to infinity, all of these values of x, and from minus infinity all the way up to 0. Now I will know what the values of x will be when the bit inside the square root has to be greater than 0. So I'll bring up my keyboard, I'm going to copy that, get rid of that. There it is. So I'm going to copy the bit inside, place that there. I'm going to select it, interactive advanced solve, solve for when x is greater than or equal to 0. Greater than or equal to 0, solve for x, and I'm told that x has to be less than or equal to 0, so therefore from minus infinity to 0, or when x is greater than or equal to 2, so when x goes from 2 to infinity. So the solving gave me the same two sets of x values, and there you have it.